So what we need to do is get an understanding of what an event is. For instance, we might have the numbers 1 through 20, and maybe someone wants to pick one number at a time. If we want to know the probability of picking an even number, we need to know two things. How many even numbers are there, and how many total numbers are there? So right now, we're just looking at how many numbers are there that are even. So if we look at this set right here, what are the even numbers? The even numbers are the set 2, 4, 6. I can use the ellipses here because I've established a pattern by having 3 elements, and I can go all the way into the number 20 would be the last number in the set. I could have written out all the numbers to 20 or use ellipses, but remember, you need at least 3 elements if you're going to use an ellipses. Which of these numbers in this set are divisible by 5? The event would be, what's the probability of picking a number that's divisible by 5? Well, what numbers are divisible by 5? They're the numbers 5, 10, 15, and 20. Any number that's divisible by 5 that results in a whole number. So what's the probability of that you would pick a prime number? Well, first you need to know what are the prime numbers. Prime numbers are any number that's divisible only by itself in 1. So what are prime numbers? It starts with the number 2. 3 is only divisible by 1 in itself. 4 is not because it's divisible by 2. 5 is a prime number. 6 is not because it's divisible by 2 and 3. 7 is a prime number. 8 is not. It's divisible by 4 and 2. 9 is not. 10 is not. 11 is a prime number. 12 is not. 13 is. 14 is not. 15 is not. 16 is not. 17 is. 18 is not. 19 is. And 20 is not. In fact, any even number after 2 cannot be prime because it's divisible by 2. So you really only have to check the odd numbers in that list after the number 2. Moving on to the next one, it says, one digit is chosen from the numbers 0 to 9. Your sample space is, 0 to 9. What if we wanted to know what's the probability of picking an odd number? Well, we need to know the odd numbers. The odd numbers would be 1, 3, 5, 7, and 9. What's the probability that the number is divisible by 3? The numbers in the set divisible by 3 are 3, 6, and 9. And what's the probability that the number is greater than 7? The numbers that are bigger than 7, which does not include 7, are the numbers 8 and 9. So, listing the probabilities, or not probabilities, listing the sample spaces and the event spaces and what we've been looking at so far has been very, very simple. But we're going to get to more difficult experiments. Not just rolling one die at a time, but what happens when we roll 2 die at a time? What happens when we flip 2 coins, or if we pick 2 cards from a deck of cards? What happens when we start having multiple things happen? So if we just roll 1 die or flip 1 coin, that's called a single stage experiment. But if something's happening, if more than one thing's happening, it's called a multiple stage experiment. So what's a way of writing out or denoting and finding all the different possible outcomes in a multiple stage experiment? Well, one way of doing it is by constructing a table. A table in particular I would only use if there are 2 things happening. If 2 things are happening, a table makes a good example. We'll go on to the next page to see what this looks like and why we would want to use a table.